Let us resume our discussion on related rates. We are done with the first problem, snowball melting. So let's go over to the next problem. A water tank has a shape of an inverted circular cone with a base radius 2 meters and height 4 meters. In fact, a picture is provided here. If water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. Let's see, what are given information here? 2 cubic meters per minute. What is this? Cubic meters, that's volume, and divided by minutes. Oh, so that tells me this is the rate of change of volume with respect to time. In short, this is V prime. How about this one? Water is 3 meters deep. Well, look at the picture. That's H. So H is 3. And what are we looking for here? The rate of change of this water depth, H prime, or the rate at which the water level is rising. On a side note, we don't know V either, but we may or we may not need it. In any case, here's the structure. We have two functions, V and H, and two of them are known, V prime and H, and then two are unknown, H prime and V. So we need two equations to identify these two unknowns. So what equation do we have? From the volume formula of the cone, we have V equals to 1/3 pi r squared H. And if you take the derivative implicitly, and we're going to get the second equation, but there's a bit of a problem. You see, V and H are good, but what is this R? Well, if we put another dependent variable in here, then we're going to get too many unknowns, and that's not going to be good. So we have to find a way to reduce it. How do you do that? Luckily, here is a hint. Look at this dotted lines. And from this dotted line, please recognize there is a plane geometry going on. We have a similar triangle, right triangle, the small right triangle in blue, and big right triangle. And the corresponding sides will be like this. R to 2, those are horizontal, is equal to H to 4, those are vertical. Now, from here you can solve for R. You see, this is equivalent to division, that's division, and you can flip this 2 to the other side, and this is what we get. And of course, 2/4 is equivalent to 1/2. We are ready now. R equals 1/2 H is going to go right here. So here, we're going to put 1/2 H. Let's simplify just a little bit. Now, I don't think I'm going to need this picture, at least for a while. So let's just go ahead with simplification. So 1/3 pi and 1/2 squared, so 1/4 H squared times another H. So what do we get? Oh, excuse me, a typo. This should be equality sign. V is equal to 1/12 pi H cubed. So there goes one of the two equations. Now let's find out the other equation. All you have to do now is to take the derivative implicitly. Take the derivative of V, so V prime, and then the right hand side, what we get? 1/4 pi H squared, and then we need H prime from the chain rule. So what do we have? We have equation number 1 equation number 2, and then we have two unknowns. These two unknown, h prime is unknown, that's something we have to find out, and v is unknown, but probably we don't need it. We'll find it out anyway. From first equation we get v equals 1/12 pi, and then what is h? It's 3, so from here you can find out the volume. But that's really an optional step because this problem did not ask you what the volume is. It asked you the rate at which the water level is rising. We want to find out h prime, so we have to work out the second equation. What is v prime? 2 cubic meters per minute, and 1/4 pi, and then this 3 squared times h prime. H prime is the quantity we are looking for. So h prime, the derivative is 8/9 pi. And this quantity is approximately 0.289 something. So I'll estimate it as 0.283. And here's the full solution, or more precisely speaking, full computation. Full solution is actually down here, along with all the explanations and additional picture. This is the 2D picture, the right triangle, and all the explanation. Okay. So much for problem 4.2, and let's move on to the next problem. A man walks along a straight path at a speed of 4 feet per second, and a searchlight is located and following him. Here's the picture. So the man is walking this way, and searchlight is following, so the angle theta is changing, and we are looking for the rate of change of this angle, theta prime. Now, what are the given information? Actually, this picture is a little bit too big, so let me make it a little bit smaller here. And alright. So what are the given information? X is the distance here is given as 15 feet. X prime, the rate of change of this distance. That is the speed of this man, 4 feet per second. And then we are looking for theta prime, right? And we don't know what theta is right now, but we may have to find out. We may or we may not. But in any case, the quantity we are after is theta prime, the rate of change of this angle. Let's see. How can I find out the relationship between x and theta here? We use the right triangle trigonometry. See, this is right angle, so we have right angle trigonometry. X over 20 is equal to tangent of theta, or x is equal to 20 tangent of, and this is the relationship between x and theta. Now if I take the derivative implicitly, I'm going to get the second equation. Let's do it. X prime is equal to 20, and what's the derivative of tangent function? Secant squared, and that's not it. We need theta prime because of the chain rule. Now we are ready. We have equation number 1 and equation number 2, and put some numbers in. X is 15, x prime is 4, and we have two equations, two unknowns. Eventually looking for a theta prime, but we may need this one in the end. So let's do it. Plug in numbers. 15 equals to 20 tangent of theta. Plug in x equal to 15. 4 is equal to 20 secant squared theta times theta prime. Shall I simplify this thing a little bit? Divide both sides by 5 and you're gonna get, okay, let's take an extra step. Divide by 5, I'm gonna get 3 equals to 4 sine of theta. And then this one is gonna be 1 is equal to 5. Okay, alright, that's a little bit better. Now from here you can find out theta and then plug it into this, but that may be an overkilling because there's a relationship between tangent and secant. Here you go. 1 plus tangent squared of theta is equal to secant squared of theta. So what do we have here? 1 plus, what is tangent of theta? We can find out from here, right? It's 3/4. That's equal to secant squared. Okay. What is secant squared of theta? Let's calculate this quantity. It's 1 plus 9 over 16, which is 16 plus 9 over 16 after taking common denominator, so it's 25 over 16. Actually, this is 3, 4, 5 triangle. Anyway, this is a quantity that'll go right over here. Let's do it. 1 is equal to 5 times 25 over 16 and theta prime. So we can find out theta prime like this. Flip everything to the other side. 16 over 5 times 25, which is 16 over 125 in radian measure. And this is the rate of change of the angle in this picture. Okay, is everything in the same viewing window? Let's remove this one. And okay, it barely went in. Barely, but it went in. Okay, now let me open up the solution and then show you what's inside. It's pretty much the same, except we have a little bit more thorough explanation with appropriate color coding and some additional picture as well in 2D geometry. So please take some time to go through with the solution. It's thorough.